Have you ever wondered if there's more to the universe than what meets the eye? Well, the answer lies in the fascinating world of quantum mechanics, the science of the very small. It's a domain where the rules of classical physics, which we're accustomed to, take a back seat, and an entirely new set of laws, strange and counterintuitive, come into play. Quantum mechanics isn't about the world as we see it, with objects having definite positions and velocities. Instead, it's about probabilities, uncertainties, and particles that can exist in multiple states at once. It's a realm where particles can be both waves and particles at the same time, where they can teleport through barriers, and where two particles can become entangled, behaving as if they are one, no matter how far apart they are. In the realm of quantum mechanics, we're dealing with particles that are so tiny they obey entirely different laws. Scene script: imagine not knowing your exact location and speed at the same time. Welcome to the mind-bending reality of Heisenberg's uncertainty principle. This principle, a cornerstone of quantum mechanics, turns our everyday understanding of how objects behave completely on its head. Now, let's dive deeper into what Heisenberg's uncertainty principle is all about. In the simplest of terms, it states that it's impossible to precisely measure both the position and momentum of a particle at the same time. The more accurately we know one of these values, the less accurately we can know the other. This might seem counterintuitive, especially when we think about how objects behave in our daily lives. If you're driving a car, for instance, you know both where you are and how fast you're going. But in the quantum world, things don't work that way. Imagine you're trying to find a quantum particle, like an electron inside an atom. According to Heisenberg's principle, the more precisely you try to pin down its location, the less certain you become about how fast it's moving, and vice versa. It's not because our measuring tools aren't sophisticated enough. It's a fundamental aspect of nature itself, a true quantum quirk. Now, you might be wondering why we can't see this strange behavior in our everyday world. Well, Heisenberg's uncertainty principle does apply to everything, but its effects are so minuscule for large objects that we can safely ignore them. For tiny quantum particles, however, these effects are noticeable and have significant consequences. The uncertainty principle is not about the limitations of our technology or knowledge, it's about the inherent fuzziness in the nature of reality. It's a hard pill to swallow, but it's a fundamental truth of the universe we live in. So, in the quantum world, certainty is replaced with probabilities. Interesting, isn't it? What if you could be in two places at once? Imagine, if you will, a world where this is not only possible, but an everyday occurrence. This is the unusual reality of quantum superposition. Now, the word superposition might sound like something from a science fiction movie, but it's very real in the world of quantum mechanics. Superposition is the idea that a quantum particle can exist in multiple states at the same time. Yes, you heard it right, at the same time. To illustrate this, let's dive into one of the most famous thought experiments in quantum mechanics, Schrödinger's cat. Here, a cat is placed in a box with a radioactive atom. If the atom decays, it triggers a device that releases a poison and the cat dies. But if the atom doesn't decay, the cat lives. According to classical physics, the cat is either dead or alive. But in the quantum world, until we open the box and observe, the cat is both dead and alive at the same time. This might sound strange and counterintuitive, and rightly so. Our everyday experiences don't prepare us for this, but this is exactly what quantum superposition suggests. The state of the cat, or any quantum system, is not determined until it's observed. This brings us to the fascinating aspect of superposition. The act of observation affects the state. The mere act of looking at the cat forces it into one state or the other. It's as if by observing we are creating reality. One might ask, why does this matter? Well, it's because such strange phenomena are not confined to the microscopic world. They have profound implications for our understanding of the universe and the nature of reality itself. Consider this. If quantum particles can be in multiple states at once, what does that mean for us, for the universe? The answers to these questions continue to elude us, and that's what makes the study of quantum mechanics so intriguing. In the quantum world, until we look, things can be in multiple states at the same time. Can two particles across the universe instantaneously affect each other? Let's dive into the uncanny world of quantum entanglement, a phenomenon that seems to defy our everyday understanding of the universe. Quantum entanglement, in its simplest form, is when two or more particles become linked in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. Sounds like something out of a science fiction movie, doesn't it? But this is a very real, albeit mind-boggling, aspect of quantum mechanics. Imagine a pair of dice. In our everyday world, the outcome of rolling one die doesn't affect the outcome of the other. Each roll is independent. But in the quantum realm, if two dice were entangled, rolling one would immediately determine the outcome of the other, even if it were on the other side of the universe. This immediate, faster-than-light influence is what Albert Einstein famously called spooky action at a distance. Einstein, however, wasn't a fan. He believed that the universe should follow local realism, a principle stating that an object is only influenced by its immediate surroundings. Quantum entanglement seemed to violate this principle. Yet, despite Einstein's reservations, numerous experiments have shown quantum entanglement to be a fundamental aspect of our universe. In the 1960s, physicist John Bell formulated a theorem that offered a way to test if entanglement was real or just an illusion. The results? Time and again, they've sided with quantum mechanics. So, we're left with a universe that, at its most fundamental level, is deeply interconnected. Two particles, once entangled, remain inextricably linked. This isn't due to any physical connection or signal sent between them, but rather, it's as if the universe has a hidden layer of reality that we're only just beginning to understand. This is quantum entanglement, where particles become inseparably linked, regardless of distance. A phenomenon that makes us question the very fabric of reality and pushes the boundaries of our understanding of the universe. What if we could harness the power of these quantum phenomena? Imagine a world where computers operate on the principles of quantum mechanics, a world where we've taken the strange and counterintuitive properties of the quantum realm and used them to revolutionize computing. That's the promise of quantum computing. Quantum computing is not just a fancier version of our current computing system, it's a radical departure, a leap into a whole new way of processing information. Today's computers, as powerful as they are, still operate on the binary system. They use bits, ones and zeros to process information. But quantum computers, they're different. They use quantum bits or qubits. A qubit can be both 1 and 0 at the same time thanks to the quantum property of superposition. This means a quantum computer can process a vast number of calculations simultaneously. Imagine trying to find your way out of a massive labyrinth. A traditional computer would try every path one at a time until it finds the exit. A quantum computer, on the other hand, could explore all paths at once. It's like having a superpower that lets you be in multiple places at the same time. Quantum computing could revolutionize everything from cryptography to material science to drug discovery. It could solve problems that are currently unsolvable, problems that even the most powerful supercomputers today can't crack. But like all revolutions, it's not going to be easy. Building a working quantum computer is a monumental challenge. Maintaining quantum coherence, error correction, creating stable qubits, these are just some of the hurdles we need to overcome. Yet despite these challenges, progress is being made. Companies like IBM and Google are investing heavily in quantum computing. Breakthroughs are being made. We're at the cusp of a new technological era, an era that could redefine what's possible. So, what if we could harness the power of quantum phenomena? Well, we're trying. And if we succeed, the future will be a place of unimaginable potential. Quantum computing has the potential to redefine our technological capabilities. We've delved into a world that's radically different from our everyday reality. A world where the laws as we know them seem to take a backseat and where the impossible becomes possible. We've unraveled the uncertainty principle, which tells us that we can't pin down both the position and momentum of a particle at the same time. We've explored the concept of superposition, the idea that a particle can be in multiple states simultaneously until observed. Then we marveled at quantum entanglement, where particles, no matter how far apart, can affect each other instantaneously. These principles are not just theoretical musings, they're driving a revolution in computing, paving the way for quantum computers that could potentially solve problems beyond the reach of our current technology. Quantum mechanics, though counterintuitive, opens up a whole new world of possibilities. It's a world that's strange, fascinating, and full of potential.